All right, today we are looking at simplifying radicals. We are going to skip ahead down here to the number 10. All right, so if we've got 12x to the fourth underneath our square root. All right, so we can do this a couple of different ways. We can give each one of these guys under the square root its own square root. And so if we break down our square root of 12, we're looking for prime factorization. So we're trying to break these down into all prime numbers. So with multiples of 12, we got 4 times 3. 3 is a prime number, so I'm going to circle it. 4 breaks down again to 2 times 2. Those guys are prime numbers, so I'm going to circle them as well. So once I've broken it down to all prime numbers, you look for any pairs. Here I have a pair of 2's. Those guys team up and go outside of the square root as one big group of 2. And then the single guy here, that 3 doesn't have a partner, so that 3 goes inside the square root. So if you got a pair, you go outside. If you're single, you go, what I say, inside, home alone. If you're single, you go home alone. Now, x to the fourth, if we're going to break that one up, x to the fourth really means we have 4 x's. Okay. Now, again, we're going to look for pairs. We have 1 pair, 2 pairs. So this pair of x's gets to team up and go out as one big X, and this pair of x's gets to team up and go out as one big X. So I've actually got 2 x's that get to go out. So that's actually x squared that gets to go out. And there's no single leftover x's, so I don't have any x's that go back home inside under the radical. Okay, so 18 now. 18. Or sorry, number 11. Breaking down the square root of 18. Again, looking for prime factorization. So 18 breaks down 9 times 2. 2 is prime, so we'll circle him. 9 breaks down to 3 and 3. Those guys are prime, so we will circle them. Once I've got all prime numbers, I look for any pairs. Here I've got a pair of 3's. Those guys team up and go outside together as one big 3. 2 here doesn't have a partner. He's a single guy, so he's got to go back inside the house home alone. Now, for r to the 5th power, we've got 5 of them. Again, we're looking for pairs. 1 pair, 2 pairs. So just like I had over here with my x's, I had 2 pairs of x's. Same thing here. These pair of r's get to team up and go out together as 1. These pair of r's get to team up and go out together as 1. So 2 r's get to come out, which is r squared, just like it was over here with x squared. But here, I now have a single r that doesn't have a pair. So the single guy has to go back inside the house home alone. So if we look at the back page, now we are multiplying radicals together. Okay, multiplying these together. Now there's a couple ways we can do this. We can multiply these guys together first, in which case I would multiply the 4, which is the outside number here, times a 1, which is just 4. And then underneath the radical, I would multiply 20 times 15, which is 300. And now I would break down my 300. So we can say 30 times 10. 10 breaks down 2 times 5. Those are both prime, so we'll circle those. 30 breaks down 10 times 3. 3 is a prime, I'll circle him. 10 breaks down 5 times 2. Those are both prime, so I'll circle both of those. Now in this case, the 4 started on the outside, so he's still there. So again, I'm going to look for any pairs that maybe join with him. So of all my prime numbers, I've got a pair of 5's that get to team up and join that 4 on the outside. I've got a pair of 2's that get to team up and join those guys also on the outside. And the only single guy I have here is a 3. So the 3's got to go home alone. So when I multiply 4 times 5 times 2, 4 times 5 is 20. And 20 times 2 would be 40. And then the single guy is the square root of 3. Okay. That's one way we could do that. The other way we could do that is I'm going to rewrite the problem. 4 square root 20 times square root of 15. Okay, the other way we could do that is similar, except here we don't multiply our 20 times our 15. We just break down our 20. So I've got a 4 on the outside. Prime factorization for 20. 10 times 2. 2 is prime. 10 breaks down 5 times 2. Both of those are prime, so we'll circle both of those. Break down your 15 as well. 5 times 3. And both of those are prime, so we'll circle both of those. So now we've got a 4 on the outside, and now I look for any pairs out of all these to join with them. So I've got a 5 and a 5, so I got a pair of 5s that get to team up and join them. And I've got a pair of 2s that get to team up and join them. And then the only single guy that doesn't have a pair is the 3. So again, 4 times 5 is 20, times 2 is 40, square root of 3. Same answer. 2 different ways we can go about doing that. Whichever way you feel is easiest for you is fine. 21. Again, we are multiplying 2 radicals together. Okay, you got 2 different ways you can do it. I'm going to do this one the second way that I showed you up here. Okay, so I've got a 2 on the outside, so I'm going to break down my 15. That's a 5 times 3, and those are both prime. Now I'm going to break down this 15, which is also a 5 times a 3, and those are both prime. So I've got a 2 on the outside. Does anything join them? Yeah, I got a pair of 5s that gets to join them, and I've got a pair of 3s that gets to join them. And I don't have any single numbers, so I'm not going to have any numbers underneath the radical, underneath the square root. 2 times 5 is 10, times 3 is going to be a 30 on the outside. Okay, now your n's. 3 and 2 gives 3 times n to the third times n squared. 3 and 2 gives me 5 of them. And I'm going to break those down just like I did on the front page. If I have 5 n's, I'm looking for pairs. I've got 2 pairs. These 2 pairs get to team up and go outside with my 30. The single n has to go back home alone underneath the radical. And that is how we are simplifying radicals and also multiplying 2 radicals and simplifying as well.